Hey guys, Mr. Backerberg here. In this video, we're going to look at transformations of sine and cosine graphs. Now what we're going to take a look in this video is the period of a sinusoid. And to find the period of a sinusoid, we take 2 pi divided by our b value. So again, whether we're looking at a sine function or a cosine function, the b value is a coefficient attached directly to our x. So we take 2 pi and divide it by b. Now a normal sine function, if we were just looking at f of x equals the sine of x, there's technically a 1 in front of that x, and if we take 2 pi and divide it by 1, a normal sine function and a normal cosine function has a period of 2 pi. But as soon as we start throwing b values in there, that means that the length of our wave is going to change. So graphically, the period is the length of one full cycle of our wave. Now, as we're taking a look at this example, we're going to perform a horizontal stretch or horizontal shrink by looking at the period of our function. So the graph we've got in front of us right now is a basic sine function, so just a plain sine of x, and there's technically a 1 in front of that x. So if we take 2 pi and divide it by 1, we get a period of 2 pi, which is why we went from 0 down to 2 pi for our graph to complete one full cycle. Now for this new function over here, we've got g of x equals the sine of 2x. So if I want to find the period, then I need to take 2 pi and divide it by this b value, and this b value is 2. So when I take 2 pi divided by 2, those 2's cancel out, so we get a period of just pi. Now I'm going to make an x and a y chart in here, but I'm actually going to add a column in the middle. So my left-hand column is going to be my x column, my right-hand column is going to be my y column. But in the middle, I'm going to put the 2x, and I'm going to show you why in just a second here. Now, to start with, for our x values, we're still going to start at 0, but my ending point is going to change, because now we only have a period of pi, so to complete one full cycle of our graph, I only need to go to pi. But I still want to end up with 5 points along the way. Now, this middle point over here where we have pi is halfway between 0 and 2 pi. So if I figure out what's halfway between 0 and pi, well, that would be pi over 2. And then if I look halfway between 0 and pi over 2, that's pi over 4. And if I look halfway between pi over 2 and pi, that's going to be 3 pi over 4. So our x values are looking a little bit different this time in my x and y table. But I've got that 2x in the middle, and what should happen in here is when I take all of these x values and multiply them by 2, that's what this 2x means, it should give me those original x values that we had from our first table. So if I take 0 times 2, I get 0. If I take pi over 4 times 2, I get pi over 2. And if I take pi over 2 times 2, I'm going to get pi. 3 pi over 4 times 2 should give me 3 pi over 2, and then pi times 2 should give me 2 pi. And looking at these 2x values is going to make evaluating this function easier as we're looking at our unit circle. So technically, when we evaluate this function, we're supposed to plug in the x value and then multiply it by 2. So that's why I made this 2x column, so that I can see what happens when I plug in these angles and multiply them all by 2. So first I have to plug in 0 for my x, and when I take 2 times x, I should get 0. Now if I evaluate the sine of 0, I'm still going to get 0. Now if I plug in pi over 4, the first thing that I would have to do is multiply it by 2. But we already did that. 2 times pi over 4 is pi over 2. And if I evaluate the sine of pi over 2, I should get 1. Pi over 2 times 2 gives me pi, and the sine of pi is 0. 3 pi over 4 times 2 gives me 3 pi over 2. And the sine of 3 pi over 2 is negative 1. And then pi times 2 gives me 2 pi, but the sine of 2 pi is 0. Now I'm going to need to add some extra dash marks on my picture because I've got an x value of pi over 4 and I have an x value of 3 pi over 4. So pi over 4 is halfway between 0 and pi over 2, and 3 pi over 4 is halfway between pi over 2 and pi. So my first ordered pair is 0, 0. I'm just looking at these outside columns, x and y, so 0, 0. My next ordered pair is pi over 4, comma 1. So at pi over 4, I'm up at 1. At pi over 2, we're back down to 0. At 3 pi over 4, I'm down at negative 1. and at pi, I'm at 0. And then I can connect all of these dots to get my sine wave. So what we should notice in here, because we had a shorter period, our graph was able to complete one full cycle quicker. So we would call this a horizontal shrink. Now in this example, we're actually going to combine a couple of different transformations. So I've got my basic sine function drawn out using that table that we created earlier. For my new function, I've got 2 times the sine of x over 2. So I'm going to create an x and a y chart, but I'm going to put that middle third column in there since we have this x over 2 happening inside of my parentheses. Now the first thing I want to find on this function is the period, but this one's going to be a little tricky. As we look at our b value in here, we have x being divided by 2. So technically the b value is 1/2. So if I take 2 pi and divide it by 1/2, well, what I would do to clean up this fraction, we don't typically like to divide by fractions, so instead I'm going to multiply by the reciprocal. So I end up getting a period of 4 pi. Meaning that I'm going to start at 0 for my x's, but to complete one full cycle, I'm going to have to end at 4 pi. Now halfway between 0 and 4 pi is 2 pi. Halfway between 0 and 2 pi is pi, and halfway between 2 pi and 4 pi is 3 pi. Now I'm going to make this middle x over 2 column just to help me out with evaluating my sine function again. So if I take 0 divided by 2, I get 0. If I take pi and divide it by 2, I get pi over 2. 2 pi divided by 2 is just pi. 3 pi divided by 2 is 3 pi over 2. And 4 pi divided by 2 is 2 pi. Now when I do that, that gives me my nice quadrantal angles, which is going to be helpful as we're evaluating our sine. Now as we're getting our y values from evaluating the sine, we do have to remember that there's a 2 in front of our function. So like when I plug in 0, 0 divided by 2 gives me 0. The sine of 0 is 0, but then I still have to take that 0 times 2. Now that doesn't affect things too much in here because 0 times 2 is still 0. But if I look at my next x value where I've got pi, plugging pi into my function, the first thing I would have to do is divide it by 2. So I get pi over 2. The sine of pi over 2 is 1, but I have to multiply by this 2 that's out in front. So I really get 2 as my y value. Now if I plug in 2 pi divided by 2 is pi, the sine of pi is 0, and 2 times 0 is still 0. 3 pi divided by 2 is 3 pi over 2. The sine of 3 pi over 2 is negative 1, times the 2 out in front is negative 2. And if I plug in 4 pi divided by 2 is 2 pi, the sine of 2 pi is 0, and 0 times 2 is 0. Now I've actually had to make my graph longer, and what we should notice is that every other line is a multiple of pi. So this line down here would be 3 pi, and this last line down here would be 4 pi. So that's going to help me out with graphing out this green function. So I'm going to look at the outer columns for my ordered pairs. So first I have 0, 0, so I plot that out. I have pi and 2, so at pi I'm up at 2, and we'll approximate that right there. At 2 pi, I'm back down to 0. At 3 pi, I'm down at negative 2, so we'll approximate that to be about right there. And then at 4 pi, I'm back to 0. So now I can connect all of these dots with my line to get my nice sine wave. And now we should notice that 2 things happened with our graph. One of the things that happened, because we have this 2 out in front, my graph got taller because it's a higher amplitude. The other thing that happened was we had a longer period, so this graph got stretched out horizontally. Now something sort of related to the period of a sinusoid is the frequency. And in order to find the frequency, we take the absolute value of b divided by 2 pi. So whether we're looking at a sine function or a cosine function, same rules apply. So for example, if we looked at just the f of x equals the sine of x function, where we've got a 1 in front of our x, this would say that the frequency is 1 over 2 pi. And all that means is that our graph completes one full cycle over the interval of 2 pi. Now if we looked at a function g of x equals the cosine of 2x, we would take the absolute value of b, so 2 over 2 pi. These 2's would cancel out, so I would get 1 over pi, and that just tells me that my graph completes one full cycle over a pi interval. So it's very much related to the period of our function. That's going to be it for this video. Thanks for watching.